Let's take a look at another common example of the command pattern in action. And this is in threading. If you've ever written any amount of Java code, you know that multi-threading is an important core concept in order to make your program be more efficient and do multiple things in parallel. Threading uses the command pattern at its very core. In fact, what you run on a thread is encapsulated in a runnable, which is essentially just a command. You didn't know it was the command pattern, did you? We'll see how threading works and how it uses the command pattern as a part of this class. Let's see an example of where we would use threading. You have a process, and basically that process wants to get some objective accomplished. The main thread in that process is doing some work. And basically, the objective of your application is to scrape the internet for news about Donald Trump. He's in the news nowadays, and you basically want to find out all you can about him from all the newspapers around the world. Now, if you think about it, this particular program has a bunch of operations that can be performed in parallel and on separate threads. It's not really a sequential or a linear operation where we do a whole bunch of processing, take the output of that, and then do more processing on it. The work this process does is parallelizable. So let's break it down and get something more specific where we say, scrape each of the top 10 US newspapers for news about Trump. We've made our objective a little clearer by specifying that we want news about Trump from 10 newspapers. Now, the main thread, which is responsible for allocating tasks, spawns off a bunch of other threads, each of which does some set of parallel operations simultaneously. If you think about the nature of this problem, there are no dependencies. If you scrape one newspaper, it's completely independent of the actions you take to scrape another newspaper. It's the same action applied to different newspapers. The results are not dependent on each other. So you could have the main thread spawn off a whole bunch of threads. One would go and scrape the New York Times for news about Trump. Similarly, another thread would go off and scrape the Washington Post for news about Trump. Note that the thread scraping the New York Times and the thread scraping the Washington Post don't really interfere with each other. You'd have a third thread which scrapes Fox News for news about Trump. So you have all these threads doing their work in parallel. Now each of these threads go off, they do their thing, and when they're done with the scraping, they're ready to hand back their individual result. Each thread has a result to offer us. We are interested in the results of all these threads. In the meanwhile, the main thread has continued to perform the tasks that it has to. Once it's done with its work, it just waits till each of these other threads complete their tasks. Once it's got all the results from all the threads, it can then aggregate these results. So basically, it now has information from all 10 of the top 10 newspapers in the US. They've come back with news about Trump. And then it can aggregate it and say something like this. There are a total of 11 articles on Trump today. 7 of these are negative and 4 are positive. The sentiment analysis on the results has been performed by the main thread. The actual scraping done by multiple threads. This is a typical use case for threading. Think about it. Think about how much faster we accomplished our objective because we used threading. There was no reason to wait to scrape the New York Times before you scrape the Washington Post. We realized this and used multiple threads. And we accomplished it probably 10 times faster because instead of 10 newspapers one after the other, we did it in one go in parallel. In Java, this entire threading scenario can be accomplished in two ways. One is how it originally used to be done, and we'll call that the old school way. And the other is how it's done currently, which typically most programmers prefer, which is the new school way. The old school way uses the runnable interface. As an exact parallel, the new school way uses the callable interface. Both of these encapsulate the operations which have to be performed on another thread. The operations and all the information that those operations need are encapsulated in the class which implements either runnable or callable. Note that these are the units of the command pattern. Alright, the old school way uses the thread inbuilt class which Java provides, and the new school way uses the executors as the built-in class which Java provides. The old school way uses thread.join on threads in order to wait for all the results to come in. And the new school way uses future.get in order to get the results from each of the callables. Let's look at some details on each of these. The runnable interface is implemented by a class which has the operations which you want to carry out on the other threads. The runnable basically encapsulates all the operations that will be performed on another thread, and if you think back to our example, the runnable will basically contain the instructions to scrape different websites. You can pass in the website as a parameter and the runnable will just execute those instructions. Similarly, it's the callable interface in the new school which will have the operations to be carried out in other threads. It's an exact analogy. Now, the old school way is more hardcore. Thread, the built-in class, represents one thread of execution, and it is this object which takes in the runnable and runs them on a different thread. In the old school way of doing things, you deal with threads directly. You're not abstracted from them in any form. The runnable is passed to the thread and executed on a parallel line of execution. In the new school way, on the other hand, you work with something called executors. Executors and the whole family of things that executors provide are helper objects that know how to deal with threads. You don't have to deal with every thread individually. A lot of helper classes, such as how to start, manage, and stop callable objects, are provided by this family of executors. Makes things much easier. Thread.join. In old school threading, the main class calls the .join method on each thread whose results it's waiting on. Calling thread.join on a thread basically means you're waiting till that thread finishes executing, puts its result in some shared memory, and then you go ahead and access that shared memory. It's a handshake. Futures are actually much more interesting and much more useful and provide a whole deal of abstraction. In the new school way of doing things, futures are objects which will hold the result of the computation by that thread in the future. Once the callable object has finished its set of operations on the other thread, it will simply return the result in the future. You get hold of the futures object and then call get on it, which automatically makes the thread wait till the results are available to you. No shared memory, no issues working with synchronization, etc. If you use a future, you get the result of the operations computed on a thread to you. Both the old threading style and the new threading style in Java directly make use of the command pattern. the runnable and the callable are what wrap a command object. They form the command object. Let's see how. If you remember, the command pattern separates the execution of an action from the action itself. It basically says this is the unit which defines the action that you have to perform with all the information needed for that action. When it's executed, I don't care about. So anyone can call execute on it at any point in time. Similarly, in threading, we define the action that we'd like the new thread to undertake. Basically, we say this is what we'd like to run on another thread in parallel with whatever else we are doing. We wrap that action in the body of an object that implements an interface, either callable or runnable, with just one method. So the callable or runnable, the interfaces both have just one method. So we wrap this action object in a callable or a runnable. We just tell this object, do your thing. And when the Java virtual machine swaps that thread into the CPU, it will be executed. We don't know when it will be done. We can wait for its result, but the act of calling execute on that object is left up to the Java virtual machine. Let's look at a little bit of example code for the runnable so things become much clearer. You can see this snippet of code on the screen where we are defining a runnable by calling new runnable and specifying the run method. So basically what we are doing is defining the command object. Now, within this command object, the execute method is basically the run method. And within this run method, the one line operation that we want to perform, this is just an example, the action is to print to screen. So the receiver in this command object is simply the screen. It's the receiver that's acted upon as a part of this command object. Alright. The next thing we want to worry about is the invoker. Notice that we instantiate a new thread and pass this runnable into it and call thread.start. The invoker in this case is this thread object. The client, which is us programmatically, calls start on that object to trigger the execution of the action. Calling thread.start, basically we call the thread to start execution. However, it's up to the JVM when it will actually start the thread. But that's a wrinkle we don't have to worry about for now. Look at this code that we have on screen now. Logically, it's exactly what we had before. But see how we define the runnable. Just take a little bit of time and absorb what you see on screen. The command pattern is so heavily used in Java, used so often, that they wanted to make the command object as easily defined as possible. They wanted to make it really easy to define command objects, that the language has now explicitly added support in the form of this simplified syntax. It's order to look at, but there's a lot less typing going on. Here is another example of the command pattern in threading, a very core concept in Java.